Hello friends, welcome back. In this session, we will talk about binary classification. This is a part of classification and it is a part of supervised machine learning. So in the supervised machine learning is broadly divided into three categories where we have regression, classification and clustering. So today we will talk more in detail about the binary classification. What is binary classification? What kind of problem actually this binary classification solves for us? That's a very interesting topic would be yeah. So you will continue this and you see the topic in details, and we will also do the practical. So the binary classification generally required when you have a data set and where you want to predict a decision. Let's say you want the decision would be happen or not happen. So for example, you have a data set, and today for this session I especially recorded a data. The data set is for the diabetic patient. So the patient has several parameters. Those parameters record for the several patients for the diabetic, whether the patients are diabetic or not diabetic. This is already data we do have. I will show you the data set. And then here what we need two classes. Our outcome would be in the two classes, either yes or no. This means 0 or 1. So as you can understand, so in this diabetic patient database, you only need to decide whether if patient has these symptoms, so is this patient have a diabetic or not diabetic. So this is ultimately output. Yeah, regression is not fit here. If you are thinking about why not we go with the regression, because in the regression you are predicting continuous value, but here you are predicting class, whether it's belong to one class or two class. So if our outcome in two classes, then we move with a binary classification. And as you know, the super short simple trainer, we do have SDCA that we use in the regression. Now we also use this in the classification. If you need for more detail, then I already added the link over here. You can go to this link here, binary classification and the details given by Microsoft, and then supported trainers for binary classification. There are several trainers supported by Microsoft.NET. I will record the further sessions on those trainers, but today we will start with the SDCA Logistic Regression. So in this the classification, we need to predict the outcome in the between 0 and 1. So that's the usual requirement for the classifications. Here I have diabetic patient database. So this CSV I already have for the patient database, where we have many columns, around about 30 columns we do have. And then finally we decide the data gives the output diagnosed diabetic, whether the patient is diabetic or not diabetic. Based on these all the parameters, age, the patient behavior, patient symptoms, these all things are available in the data set. So today we will try to understand about how we use binary classification. So let's continue without wasting further time. So the first and topmost demand is you need to integrate, you need to add the nugget packages. So let's import the nugget here. Once nugget is imported, then this class I already prepared the data contract class, which is input and output. So in this binary, in this classification, the model gives us output in a three terms. So let's say this is the input. That's pretty clear. That's you already understood. And the output is would be the predicted diabetes, means the level where we predict is a Boolean type, yes or no. And then the probability, what is the probability ratio given by the model, and the score. So score given by the model, and based on the models we decide the probability. Here we use sigmoid function. I will record further sessions on the sigmoid, where you will understand what exactly means by sigmoid. So let's start model training with this session. So first step, you need to load the data. So load the data from CSV file that we want to load. Here I think we can easily copy and paste the old code which we already have. So this is the code, always utilize, so no need to write again and again, just to save a time. Here we have ML context. I created ML context and iData view where we need to load our data. So just change the class diabetic class name. Let me copy it, diabetes input. So there is no change in the pipeline, that looks similar, and you need to change the diabetic data, diabetes data set. Okay, diabetic data set. This is our CSV. Let's load the CSV. But before loading, we need to execute the model class. So let's execute this first. Definitely, if model class is not executed, yeah, this will give the error. That's pretty nice. It's pretty clear. You already know till now based on your trainings. So now it's okay. We will load the model data. All right, good. Data is loaded. So once the data is loaded, what's the next stage, guys? The next stage is to perform the pipelining. Here we need to perform the pipeline. Do you know why a pipeline exactly required? If you are new on this session or you have any confusion, please refer to the roadmap and refer to the regression where I recorded several sessions. Why pipeline is required, what is data cleaning, what's the data wrangling, and what is the data feature engineering. These all the detailed sessions are available over there, so you can continue with these sessions. I would say that would be good for you if you have any confusion. If you already know that, you can continue with this session. So here we need to perform the data cleaning, perform the pipeline and encoding. That's interesting. What is encoding actually? One hot encoding, we already talked about the one hot encoding in the previous sessions. One for our model, it's always required you will provide the numeric data to the model. So in this CSV, we have seen several data in the text format. You can see the several data, let's say gender, and then there are several data you can see in the text format. So these data we need to convert into one hot encoding. So one hot encoding is, if you wanted to understand in simple terms, it's nothing special. One hot encoding means the model will create a dictionary along with our text data. So with text data, model will give the numbering for each unique data, right? That's one hot encoding. Dedicated session already recorded for this, so you can refer to this if you have any confusion. So to saving a time, let's say I already have the encoding. Let me copy the encoding for you. This one here, what you can see, the transformer, it's pretty easy. Categorical one hot encoding. There are several columns which are text based. So these all the text based column we need to perform the one hot encoding to train our model. And then once all the text columns are encoded, and then we will add them into feature column. So in the feature columns, I added all the columns. So to saving a time, I already copied this data so that we can reduce the video length. Once these trainers are these one hot encoding is performed, then we need to add the trainer. Here we need to add the trainer, and the trainer is belongs to binary classification and the SDCA. So that's trainer. So it's pretty simple. Only change is here binary classification because the trainer belongs to binary classification, and then we say SDCA Logistic Regression, and the column label column name. What is the prediction column that you know, label column name, and then feature columns is the feature column. So this is pretty simple, easy, as you already understand in the regression. Let's execute this. Once this is executed, you know what the next is we need to prepare our data set in the train and test. So let me copy this as well from the previous code. Why I'm doing this, guys? This is only to saving a time, nothing else. Copy this because this will never change in your machine learning model training. Any model you train, you need to perform these things. These steps are mandatory for machine learning model training. So here what I have, the train and test data set, and then we will fit our pipeline then we'll perform the transformation with the test data set. Let's do that. Okay. It will take slight time. It's based on the data. Let's say how much data you do have in your CSV file. In this CSV roundabout, I think 1 lakh records I do have. So that will definitely take a time, because the fit method, when you use the fit method, what exactly this will do, it iterate all the row, one by one row in the data, and then perform the encoding of what we have, and then concatenate the columns into the feature columns. So this is the real utilization of the model training here performed in the fit method, which I use here. And then after the fit, it will transform. This means it will gives you the model as a data. So it will give the iData view in the prediction, where we can further use for our evaluation. So let's wait a time. Maybe I can pause my video, because this will take quite long time. Okay, the model training is done. As you can see, it took 1 minute 43 seconds. It's up to the data set which we have and your machine configurations as well. And once your model is trained, we need to evaluate the model. So the model evaluation is evaluate the model. Here, this is our classification with change, binary classification, evaluate, and the column name, which column we do have as a column name, input column. So this is diagnostic diabetes. Okay, and then once this evaluation is done, what we need to print the evaluation matrix. Display evaluation matrices. Okay, this is going to be very interesting, and I would not explain in the detail about the evaluation matrix in this session, but here I like to explain you the accuracy of the model, what accuracy level given by our model. In the next session, I will give you in-depth understanding what is evaluation matrix, what is confusion matrix, because the classification have a more matrices as compared to regression, where we understood the regression in the previous sessions. So here we have several evaluation matrices and confusion matrix as well, where we see true positive, true negative, false negative. I will explain you in the further details. So you will continue, keep your practice. Let's do your practice here, because you need to do the practice, then only you can learn and understand the machine learning. Otherwise, guys, it would be very difficult if you only watching a video and don't try to do your practice. So you have to come out from your comfort zone, and then definitely you can change your career. If I can promise to you, if you continue practice with me in next 6 months, you will definitely see the bigger change in your career. So don't wait, continue watching series, and then continue doing your practice as well. Thank you. See you in the next session.